Hello dear students, so let's discuss the question number 2 of IMO 2025. In this we have given two circles intersecting at a 2 points A and B. The their centers, the center line intersect the circles again at a C and D. So C, M, N and D are collinear and lies in this order. Then we have a P is the center of a circle passing through CAD. So this is a point A. So we draw a circle passing through CAD having center is P. So let's say its center is somewhere here, and if we connect from A to P, it intersects the circles at E and F. Intersect the first circle at a E point and the another circle at a F point, right? Then what we have now, we have a P is the circumcenter of a triangle ACD. Okay, we can make a triangle ACD. And line AP that we already draw. HB the orthocenter of a triangle PMN. So PMN triangle if we make, this is a triangle PMN. So H is the orthocenter of a triangle PMN. Prove that the line through H parallel to AP is tangent to the circumcircle of BEF. So basically B point is this, right? As the two circles intersect at A and B, so this point is B. Okay, so we have this diagram. Okay, so we can see the circle also here that is passing through B, E and F. Now we have to find out the orthocenter, but before that we can see one thing, that if we extend AM line is nothing but a center to center line, isn't it? Sorry, PM line. P is the center of a bigger circle and M is the center of this circle, first circle. So we can say this center to center line must be perpendicular to the common chord and bisect that common chord. And you can see that the common chord is AC. That AC is the common chord of these two circles. So if I extend this line, so I can say this angle is perpendicular and this bisect this also, right? And the same thing we can say about this one. We can extend this line P and it is perpendicular to AD and bisect it also, because AD is a common chord of a second circle as well as the bigger circle ACD passing through. So we can see that AC and AD are perpendicular to PM and PN. AC and AD is perpendicular to PM and PN, means if I draw the perpendicular from M to PN, that must be parallel to AD, isn't it? That must be parallel to AD. And if I draw a perpendicular from N to PM, it must be parallel to AC, right? So that is the one point that we get. So, and this will be the orthocenter of a triangle, and we can further join PH and extend it. Let's say it meets the line at a point K. And we can also say that as it is a perpendicular from P on a chord CD. CD is a chord of this bigger circle. So K is the midpoint of CD. In CK is equal to KD. Also we can say that this line PK bisect the angle CPD. This PK line, as we can see, CP is equal to PD, has the radius of a bigger circle, and PK is a perpendicular, or it bisects the chord. So we can say that this angle is also bisected. This one, this angle is equal to this. So do we know this angle? Do we know the angle CPD? So to get the angle CPD, we can use this angle. This is the angle A. This is the angle A. So we know that if we draw an angle opposite to A, if we draw a cyclic quadrilateral, right, then the angle opposite to A is 180 minus A. Then the angle at the center is double of that. So it should be double of 180 minus A. Angle CPD is double of 180 minus A. Or you can say twice of 180 minus A is basically C plus D. As A plus B plus C, A plus C plus D is 180, as it is a triangle. So I can say it is twice of C plus D, and both these two angles become C plus D each. So this part of angle is C plus D. This part of angle is also C plus D. Right? Now again, if we consider the triangle PAD, if we consider the triangle PAD, AD is a chord of a bigger circle again, and this P and L is a perpendicular bisector of that chord. So we can say that this angle PAD is also bisected by PN, isn't? So I can say angle APN is equal to angle DPN. Do we know this complete angle? Do we know angle APD? So APD, again we can use a angle in a same segment. Angle APD is equal to angle ACD, which is C angle. So both the angles becomes, sorry, APD is the center angle at a center, is twice of ACD, twice of ACD. So that is twice of C. Isn't APD is twice of C. So you can say half of them is C. So this angle is C, and this angle is also C. Similarly, we can consider the triangle PAC. If we consider a triangle PAC, again you can see PM is a perpendicular bisector of a chord AC. So that angle is also bisected. PM bisect the angle APC. So APM is equal to PMC. Right? So do we know the angle APC? APC is again equal to ADC. As we can see, APC angle is equal to ADC angle in the same segment. That is angle D. Sorry, AP is twice of angle ADC because P is a center, sorry. So angle at the center is double of angle. So you can say it is twice of D. So if you bisect them, that is D and D. So the two angles becomes D and D. This angle is G and this is also D. Okay, so we get some angles, and can we find out this angle AKP? Can we try to find out this angle AKP, this angle? So this angle, Basically we can use as we know PK is a perpendicular bisector, so it is bisect the angle also, and we already see that the angle CPK is C plus D, isn't it? As we know CPK angle is C plus D, and CPA angle is 2D, so we can find out the angle APK. If we subtract them, that is C minus D. So this part of angle is C minus. So let's see one more angle chasing in this. As we have at this point is H, and we already find out this angle, right? So as also we can say this angle is equal to this, because this is a AB line which is perpendicular to CD line or MN line, and this is also perpendicular to CD PH line. So whatever angle is this, if I assume this angle is theta, however we know this value is C minus D, but let's assume that it is theta for now. So this angle is also theta. Now if we see that this BE line, this BE line or BER subtend an angle theta at A. So what angle it will subtend at a center, that is 2 theta. So this is theta, this is 2 theta. Sorry, not this one. That is the arc BE. So we have to connect E also. Okay, so this angle is theta. And similarly we can see that this BF line or BF arc also subtend angle theta. So it will also subtend an angle 2 theta at the center. This angle should be 2 theta. Okay. So now as we can see that both are subtending angle 2 theta, again this 2 theta is by that BF, like this. So you can find out this angle becomes, if this is 2 theta, this becomes 90 minus theta. And if I extend this line, this ME line, if we extend it, so this angle will be 90, as this angle is 90 minus theta, similarly as this one is 90 minus theta, means if I write MEB angle is 90 minus theta, and then this angle is 90 plus theta. If I say this point is, let's say, R, so I can say angle BER is 90 plus theta. Now you can see also that angle BER plus BFR is equal to 180, isn't it? So we can say it is a cyclic quadrilateral, means this point R also lies on this circle. So we get this cyclic quadrilateral. So BEF is also passing through R. Okay, so we see that this angle is 2 theta, and okay, and we also see that B, E, R, F are cyclic, right? Now let's try to find out this angle. As we know, HM is parallel to AD. So if this angle is D, then this is also D. And similarly, AC is parallel to HN, so this angle is also C, right? Now I just want to find out this angle. Again, by angle chasing we can do that. Like, first we can see that this angle, if I name this point is let's say Q, so QME angle is made by the arc QE, right? So QE arc can be written as QB arc minus BE arc. So QB arc is equal to QA arc, right? Minus BE arc. So we know QA arc angle is 2C because QA make angle C at a circumference, so at a center it is 2C, and BE is 2 theta, which is twice of C minus D. So this becomes 2D. So total angle QME is 2D. So means this angle is also D. In a similar way, you will see that this angle is also becomes C. So in fact, H is the incenter of a triangle RMN. For a triangle RMN, H is the incenter. And if I join RH, this must be the angle bisector. Isn't it? RH is the angle bisector of angle R. So what I can see that somehow if we figure out that RH is parallel to AP, RH is parallel to AP as well as RH is tangent to the circle, then we can see that our proof is complete. So can we prove, or can we try to prove that RH is a line which is parallel to AP line? So what we know about RH? RH is the angle bisector. Do we know the angle R? For the angle R whose bisector we made, that we can say using the triangle MEMRN. As we already know that angle M and angle N are 2D and 2C. So angle RMRN is that 180 minus 2D minus 2C. So if I say I extend this line MHR to intersect it at S, so I can see that this angle NRS is half of that, isn't it? So then we can find out this angle also, angle NSR, as this angle is 90 minus G minus C, this is 2C. So if we add them and subtract from a 180, we will get this angle. So 90 minus G plus C, and if we subtract from 180, it is 90 plus C minus D, and this angle is already 90. If I say this point is, let's say, G, then we can find out angle SHG. SHG becomes equal to 90 minus 90 plus C minus G, which is D minus E. Okay, that is interesting. We have to, that is a negative angle, that is SHG. Okay, let's see it again. MRN is 180 minus 2D minus C, so it is 180 90 minus D minus C. Then we use a triangle NSR to find out this angle. So we say it is 90 minus G minus C plus C, that is 90 minus G plus C. Okay, so NSR plus C minus D. It is 90 minus C plus D, NSR. So if we subtract this angle, we get C minus D. So that is correct. If this angle is C minus D, means angle SHG is C minus D. That is same angle which is this one as well as this one. So you can say RS is parallel to AP. Now the only thing we have to prove that this is tangent to this circle. So if we say that this angle, as we already see, this angle is 90 minus C plus G, sorry, 90 minus G minus C. So this angle will also be 90 minus G minus C, HRN angle, HRM. So we have to prove that this angle should also be 90 minus C minus D. Then we say it is a tangent, alternate segment theorem. So can we prove this angle is 90 minus C minus D? So to prove this angle is 90 minus C minus D, if I name this point is, let's say, I, so we want to prove angle NFI, we want to find out angle NFI. So we already know the angle N is 2C. Do we know this angle? Can we find out this angle? This angle we can find out even from this triangle also. If I say this point is H, is actually already, or not H, let's say we say this is V. So you can see that angle NFI, if we want to find out, first let's find angle NIF. So angle NIF is angle AIV. We assume this point is V. So AIV, you can see in a triangle, AIV triangle, this angle we know, if we assume it is theta, then this is 90 minus theta. And theta is what? C minus D. So NIF angle we get. So NFI is 90 minus NIF. So NFI angle from a triangle NFI, we can say it is 180 minus angle N, which is 2C, and this angle 90 minus C plus D. So do we get some good angle? 90 minus C minus D. So this is same as the angle that is HRM. HRM angle is 90 minus C minus D, and this is also 90 minus C minus D. So we say that HR is tangent to the circle.